Here is the answer for the day 3 Bauwerk. Express the number in standard notation. So question A and B are numbers that are in scientific notation. I know that they're in scientific notation because of their format. There is a number, and then there's a multiplication symbol, and then the number 10 with some power. This is scientific notation. Standard notation is just a regular number, no times 10 with any exponent. So to make this conversion, we're going to use the meaning of the times 10 to the third power. 10 to the third power is the number 1,000. So what do you get if you take 3.45 and you times by 1,000? You would get the answer 3,450. Now that answer can be done mentally or on a calculator, or you can kind of work it out in like a step-by-step process like this. If the exponent on the 10 is a positive 3, then that means to multiply this number out here by 10 3 times. Each time you multiply by 10, the decimal point would move one position to the right, creating a larger number. So times by 10 once, you'd get 34.5. Times by 10 a second time, you'd get 345. And times by 10 a third time, filling that in with a placeholder 0, you'd get 3,450. When a scientific notation number has a positive exponent on the 10 and you want to change to a standard number, you move the decimal point to the right as many times as what this exponent indicates. Question B. Here is our scientific notation number. To get a standard number, we would take this coefficient, 1.041, and multiply it by 10 to the negative fourth power, either in our heads or on a calculator, or doing it in kind of a step-by-step fashion. If the exponent on the 10 is a negative 4, then that means to multiply by 1/10 4 times. Each time you multiply by 1/10, you create a smaller number. We can get to the answer by moving the decimal point to the left 4 times. The first time we move to the left, we would get the answer 0.1041. The second time, and filling in with a placeholder 0, we would get 0.01041. Moving in another position and filling in with a 0, we would get 0.001041. And moving it a fourth time and filling it in with a 0, we would get 0.0001041. And that's the answer. When a scientific notation number has a negative number as the exponent on the 10, you can change to a standard number by moving the decimal point to the left as many places as what this exponent says. Now let's do the reverse process. Express these numbers in scientific notation. Question C, 23.731. Scientific notation has a certain format where there is a number called a coefficient, and then there's a multiply sign, and then 10 with an exponent. The coefficient number is always a number between 0 and 10, meaning it's a number that has only one digit to the left of the decimal point. So we're going to take all of these same digits, the 2, the 3, the 7, the 3, and the 1, and rewrite them. But when we do this, we're going to put the decimal point so it comes after the 2. Now write times 10. And we're going to figure out an exponent on the 10. How many times would you multiply that number by 10 in order to create the original number we had? We would have to multiply by 10 only one time. Because if you multiplied by 10, what would happen is this decimal point would move one spot to the right, and that would create the 23.731. To change a number into scientific notation, you rewrite all of the same digits, but you put the decimal point after the first digit. Then you decide on what exponent do you need on a 10 in order to recreate the original number. Now let's try D. We're going to rewrite all of these same digits, but put the decimal after the first non-zero digit. So it will become 3.6. Then write times 10. We now have to figure out the exponent on the 10. What would it need to be so that this number that we just wrote down, 3.6, creates that original number? It would need to be a negative number, and the decimal point would need to be 4 positions to the left of where we just put it. So it would be a -4. Do you see why it's 4 positions? We're writing this part of the number, and when we write it, we're putting the dot right there after the 3. But the decimal point is really farther out to the left. It is 1, 2, 3, 4 positions to the left. And so the exponent on the 10 needs to be a -4.